Good morning, everybody. Welcome to Going Electric, retrofitting New York City's multifamily buildings. Thank you all for joining today's program. My name is Chris Halfnight, and I lead Urban Green's policy work. John Mandyke, who was going to moderate today, was called away on a family matter, so I'll be stepping in to moderate today's program. John was, however, available to send a short pre-recorded note about our upcoming conference, which is focused on a topic very relevant to today's discussion, greening New York City's grid. And we're going to roll that for you right now.
Hello, everybody. I'm John Mandyke, CEO of Urban Green Council. I'd like to invite all of you to join our online annual conference this year on June 17th. This year's conference will be about unlocking the grid, getting renewables to New York City. And I have to tell you, the timing could not be more important for this discussion. With the closure of Indian Point Nuclear Power Plant, our grid in New York relies now nearly 100% on carbon-based fossil fuels. We have to change that grid to get to our zero carbon future. This conference is going to break it all down. We'll look at the barriers we need to overcome for generating greater renewable power, for transmitting greater renewable power, and then what we need to do from a distribution standpoint with our local grid once that power gets to New York. I hope you'll join us for the event. We're going to kick it off with an amazing keynote panel with literally the power brokers and the decision makers in New York State. We'll have the CEO of NYSERDA, the CEO of the New York Power Authority, and the CEO of the New York State Department of Public Service. They will frame the context for us as we examine these critical issues. We're going to deliver the conference through an engaging online format. It's not going to be like your normal webinar. You're going to find a truly amazing experience. I hope you'll join us. Visit urbangreencouncil.org to register and to learn more, and I'll see you at the conference. Thank you.
Great. So we hope you can all join for that conference. We have a great program for you today. It's anchored in about a year of Urban Green's engagement with stakeholders and experts to produce our recently released report, Going Electric. We're going to start with about a 20-minute overview of the report. Then we're going to move to about a half hour of discussion with our panelists, and then we'll save about a half hour for audience Q&A after that. To get us started, I'd like to introduce Urban Green's research lead, Sean Brennan.
Great. Thank you, Chris. So I'd like to dive into what Chris was just talking about with Going Electric, which was released on Earth Day last month. And we're very excited to share all of our findings with you. So this is the culmination of about a year's worth of work. What I'm going to share with you today is why we think electrification is so important in New York City and how this research was developed, as well as what we concluded in the report and what we think are the next steps for heat pumps in New York City. So that'll be a good segue into our panel discussion. And of course, we'll have lots of time for your Q&A. So first off, electrification in New York City is actually something that we're fairly familiar with. So back at the turn of the 20th century, the first public electric utility was founded on Pearl Street. And that's just a few blocks away from the Urban Green Council office. And that gave rise to the electrification of light. And so that's basically all we're doing here is taking an energy end use that runs on fossil fuel and then switching it over to electricity. And it wasn't a straightforward or quick path to electrify lighting. It actually took about 50 years from the turn of the 20th century to get the last gas lamp off of our streets. And so there were a lot of different players, there were a lot of different manufacturers and companies competing for the right technology. And we see some of those things today as we begin the early stages of electrifying the last two energy end uses, heating and hot water. Now, to give you the landscape of other factors that are going to impact electrification in New York City, I want to show you a timeline of some of the things that are going to influence our buildings over the next decade. First off, Local Law 97 was enacted last year, and that is going to put carbon emissions limits on our buildings starting in 2024. Now, that law looks at electricity in one static way for this first initial compliance period. But that's not how our grid works. It's changing every day. And so actually just last month on April 30th, Indian Point Unit 2 was decommissioned. And so we lost about a gigawatt of clean power. And next April, we'll lose the last unit, Unit 3. And that will be the end of nuclear power in our region. So that means that our grid is going to get a little dirtier in the short term. We do expect that gas is going to fill most of that gap. And we actually have run some models and looked at other research studies, and it looks like the grid is going to get, in the short term, about 20% dirtier than it is today. But from there, it's all upshot as we head towards 2030. And so we have government buildings that have mandates to get solar on their roofs. We have wind farms that are planned, and we have new transmission interconnects that are permitted. So given all those complications, why should we electrify now? Well, first off, we looked at building emissions across the state and in New York City. And we found that 2/3 of building emissions come from burning fossil fuels right on site. So that's a very interesting trend that was pretty much the same at the state level and the city level. And it's a trend that's even stronger in our multifamily buildings. So we know from the local law 87 audit data that almost 3/4 of building emissions, multifamily building emissions, come from heat and hot water. So electrification can take a big chunk out of these yellow slices of the pie, but it can do that while improving our air quality, both inside and outside of buildings. And that, as we all know, is becoming a bigger and bigger issue as we all look to protect our lungs from pollution. So that was our goal with going electric. We want to kickstart electrification in New York City's existing multifamily buildings. So at the beginning of 2019, we convened about 40 advisors made up of building owners, engineering and architectural consultants, manufacturers of heat pumps, and of course, electric utilities. And through forums and interviews, we sought to first identify those technical and regulatory hurdles, and then to find out what are the 9 next steps that will set the foundation to electrify these buildings in the next 5 years. So right from the onset of this process, we found that not all of the advisors and ourselves were aligned in terms of what modern heat pumps were, in terms of the technology and their capabilities, or how they had been implemented in New York. So these are some interesting ideas that we heard continually debated in the forums. And I just want to introduce them to you so you have them in the back of your mind so you understand how the research developed and which questions we sought to answer. The first is that there is no business case for heat pumps, meaning that they're very expensive and there's no way that they're going to pay for themselves given the high cost of electricity. The next was that heat pump technology just isn't ready for New York City. And that has a double meaning. First, that some consultants felt that the cold winters we experience in New York are too cold for an air source heat pump to actually give the right capacity of heat. And the second is that heat pumps are not ready to serve big and tall buildings like we have in New York. And the last idea that we heard was that our grid is too dirty to justify the replacement of oil and gas heating systems. And that alludes to the point that I was hitting on before, that most of our electricity generation will come from gas in the short term. So why would we replace systems that burn natural gas in our buildings? So that led us to identify these key challenges. First and foremost, we understand this is a substantial financial cost. That is the biggest hurdle to installing heat pumps in multifamily buildings today. The next included a few technical information gaps that we really worked hard to get alignment within the advisors and then put into the report. So any building owner is faced with a heat pump system selection issue right from the set. And so they can choose either a unitary heat pump or what a contractor might call a mini or multi-split system. You'll see those in single-family homes. Or a centralized system, which a contractor might call a VRF. So there is no simple, clear-cut solution for all multifamily buildings. Each will have to choose the system on their own based on things like outdoor space availability and electrical capacity. Electrical capacity is the other big information gap that we have. We actually don't know how much current or how much electricity is going into our multifamily buildings, nor how much is being routed up to the apartments. So that's the first step in any heat pump feasibility study, is to determine how much current is flowing through your multifamily building. And if there's not enough space available, or what they call headroom, then an electrical upgrade will be needed. Third, there is a lot of regulatory uncertainty. So that comes in a few different forms. I haven't listed them all here, but a big one was potential refrigerant risk. So that's a health and human safety concern that's been well addressed by ASHRAE. But there's also the concern of a building owner investing in systems that use refrigerant that could be banned in the future. So what we found with that issue was that there's a long lead time for those, and there's a long grandfather period, as we've experienced with our 20. Is banned, but still currently in use for the time being in New York. Finally, this is new ground for the rental sector. So conventionally, New York City tenants do not pay for their heat separately, but heat pumps will make that very easy for landlords to do. And so that brings up a lot of issues, not only for market rate apartments, but also for the rent regulated sector. So let me dive into that first challenge a little bit more. So financial cost, how much will a heat pump install cost? So this is comparing central to unitary systems, both cost on a per square foot and per dwelling unit. And so you'll notice right away that we found that central systems are probably going to be more expensive than unitary systems to install, about 20% more per apartment. So this is a big problem in terms of information availability. This is based on 12 recently proposed estimates and studies for heat pump installs in New York within the last 5 years, including design, material, and labor. But it's by no means an apples to apples comparison. Each of these buildings differed in terms of size, height, and occupants. But it's a good starting point. And what we noticed was that there's a lot of risk and uncertainty built into these estimates. And so we're expecting those prices to fall over time. The next big question is, will heat pumps actually save carbon? So we found that yes, absolutely. By 2030, most heat pumps are going to cut carbon in multifamily buildings. So let me introduce you to this graph on the right. On the x-axis, we have heat pump performance of a future system you might install. And on the y-axis, we have the existing system fossil fuel efficiency. So any green dot means that there was a scenario where we replaced an old system with a new heat pump at a certain performance level, and we save carbon. In fact, there's only 3 dots at the lowest heat pump performance, 1.25, that we didn't see a heat pump or a carbon savings. Now, you're probably saying, Sean, that's great for the grid in 2030. It looks very rosy. But what about tomorrow's grid? We found that starting tomorrow is actually fine too. So this is the same model, looking at tomorrow's grid where Indian Point is gone. And we find that any heat pump that performs above a COP of 1.75 is also going to save carbon in our multifamily buildings. So that 1.75 number is pretty important. That is the minimum performance that NEEP specifies for heat pumps to be in their inventory. And what we found was that there are some experimental studies out there that look at heat pump performance in the field for states like Minnesota, Vermont, and Massachusetts. And most of those studies are finding annualized COPs between 2 and 2.5. So we're pretty confident about heat pump performance in colder climates, even colder than New York. And we're also pretty confident they would save carbon now. So let's take a look at the 9 key steps that we found in the report. I'm going to go over 4 here, and we'll probably explore some more in the Q&A. So first off, there is a huge need to demonstrate the technology in New York City. We need to see what a project of this scale would look like in an existing multifamily building. Second, we need to increase the incentives to offset the big capital costs involved here. Next, we need to not only support the heat pump install costs, but also the cost of the electricity to operate them. And we can do that through better electricity rates. Finally, we want to start electrifying at least one step at a time. So building owners actually have options here. You don't have to do it all at once. On that first point, we found that more than 30 new construction multifamily projects are either using or planning to use air source heat pumps. So this is clearly a technology that is being specified and trusted by developers. But no large heat pump retrofit has been done for the whole building with tenants in place. So that's a striking difference. But there have been some experiments, and what you can see on the right is an experiment where a building replaced a PTAC unit, expanded the hole, and then placed an outdoor heat pump unit in the same place. So the tenant is very happy, but the building did not go forward with the rest. So far we've seen a lot of experimentation, but not on the whole building scale. And that's really what we need. But where do we start? So in New York City, we have about 16,000 multifamily buildings that are larger than 25,000 square feet. And what we did was we tried to identify characteristics that would make them a favorable target for electrification. So I'll walk you through those right now. That's heating systems that are hard to upgrade. If you have one pipe steam in your multifamily building, there are fewer energy efficiency measures that you can make to that system. And it's also very, very hard or completely impossible to convert it to hydronic. The next is the apartment or building owned by the occupant? So we're talking about condos and co-ops here. And granted, condo and co-op boards are not necessarily easy to deal with, but at least their incentive structure is aligned so that they know if they invest money into the building, they are going to reap the rewards. Finally, if a building uses a costly fuel, then heat pumps could actually be less costly to operate than a steam system that runs on fuel oil, district steam, or if you have electrical resistance baseboard heaters. So nearly 2/3 of our multifamily buildings have at least one of these favorable electrification characteristics. And the best targets have all 3. So that's about 480 buildings, or 3% of our stock. So we have lots of great demonstration targets available. Next, we'd like to increase the incentives to offset these costs. So recently, the PSC directed over $450 million to utility-run heat pump incentive programs that will run through 2025. So there's a lot of new money being injected into the system. And while we're doing that, it's an opportunity to collect and share the market data about these installs. So what you're seeing on the right is a system put in place in Massachusetts, which mandates that all projects that get incentive money share things like project cost, the contractor involved, the model of the heat pump that went in, and the location. And so they've created this dashboard that gives everyone that information. And so you can see that, we have a distribution of prices, and you know exactly what the cost per ton should be if you're going to install a heat pump in Massachusetts. So we think this is a great dashboard, and we'd love to see something similar implemented in New York. Next, we'd like to support those heat pump customers as well. So heat pumps are going to be expensive to operate. Electricity is about 5 times the cost of natural gas per unit of energy. But heat pumps do more than just consume more electricity. They also deliver value to the grid. So they can do that in lots of ways, one of which is by delivering more efficient cooling in the summer. So there are some experimental utility rates out there that are being looked at. One of them is called demand-based rates. And what that implies is that instead of billing customers for the overall amount of electricity they use, or if you look on the right, it would basically be the area underneath the curve. So how much electricity in kilowatt hours do you consume over a day or over a month? Instead of doing that, you would bill them on how much peak power they consume. So you wouldn't look at the area under the curve, you would look at how many watts they're consuming on a given hour. So you can see here, let's assume that these two apartments in New York City are using the same amount of electricity per month, but the purple apartment has only half the peak that the yellow apartment has. And so it gives customers the opportunity to think, do I need to be running my heat pump while I use a hair dryer and while I run my coffee maker? Or can I do those things in sequence? And I'll use the same amount of electricity, but I can lower my utility bill. Finally, building owners do have options. And so we're going to run through 3 of these options to the first is to electrify just your hot water. So you would leave your heating system in place, but then install air-to-water heat pumps or wastewater heat recovery heat pumps to deliver that hot water. And so that's a picture of a system that does wastewater heat recovery on the right. And this is a great technology that's been used on the West Coast extensively, and we're hoping it makes its way to New York soon. But essentially, before your wastewater enters the sewer, this system will extract the heat and then deliver that heat to whatever equipment produces your hot water today. The next is to retrofit just one part of the building at a time. And so that makes a lot of sense if you have an office space or some common lobby space in a multifamily building. You could start there, or you could do it one floor at a time. And finally, you could upgrade the building to be heat pump ready. So this is essentially splitting the project into 2 phases. In the first phase, you would convert your, let's say, steam building to a hydronic building, meaning that you circulate hot water rather than steam. And that's advantageous because heat pumps can actually deliver hot water at those temperatures, but they cannot reach the temperature of steam. So in the first phase, you would convert to a hot water system. And then in the future, when you're ready, you would convert to a heat pump system to deliver the heat to that loop. So those are just 4 of our next steps. We have 9 in the report. So I really encourage you to take a look where we go into more detail on these steps, as well as the challenges that we found. Thank you very much.
Great. Thanks very much, Sean. That's a fantastic overview of the report and its findings. We're now going to be turning to our panel discussion, and we have an excellent group assembled for you today. We have 3 experts, all of whom participated in a year-long stakeholder engagement and discussion leading to the report, and all are bringing different perspectives. So Sean's going to be joining the panel, and I'm going to introduce the panelists now. So first we have Kelly Doherty. Kelly is Vice President at First Service Energy, which is part of First Service Residential. Hi, Kelly. For those who don't know, First Service Residential is the largest manager of residential properties in North America. So in that capacity, Kelly works extensively and tirelessly on long-term efficiency strategies for the many properties in the First Service portfolio. Second, we have Donovan Gordon. Hi, Donovan. Donovan is Director of Clean Heating and Cooling at NYSERDA. I think for this audience, it probably goes without saying, but NYSERDA is the New York State Energy Research and Development Authority. It provides a wide range of research, analysis, technical expertise, programmatic, educational, and financial support to advance energy efficiency and clean energy across the state. Welcome, Donovan. And last, but certainly not least, we have Chris Raup from Con Edison. Hi, Chris. Chris is the Director of State Regulatory Affairs at Con Edison. In that capacity, Chris manages state regulatory engagement on a range of subjects, including energy efficiency, smart meters, electric vehicles, and today's subject, heat pumps. He's also led the utilities development of alternatives to natural gas pipelines, known as non-pipes alternatives. As we move to the panelist discussion, I just want to remind the audience that you can enter your questions for the audience Q&A, which will come after, below your video. You can just enter the questions there, and you'll see next to the questions that have already been submitted, there's the option to click a little thumb, which is to upvote a question. The more upvotes a question gets, the more likely it is we'll pick it in the audience Q&A portion. So Kelly, you work with many residential property owners and managers. We've heard about the challenges covered in the report. The benefits of heat pumps are clear: significant carbon savings, more comfort and control over temperatures in apartment units, better balanced buildings, access to cooling where it didn't exist before, and better indoor air quality, and some contribution to improved outdoor air quality. What's the building owner perspective on heat pumps? Why are we not seeing more retrofits? Is it just cost that's holding us back?
Cost has a lot to do with it, unfortunately. But there are some other factors too. But cost I would break up into two pieces. So Sean actually went over some of this, but the upfront cost of the installation of the project, as well as the ongoing cost to operate that system. But there are some other factors that we've seen boards, condo and co-op, have some difficulty getting heat pumps to be the option that moves forward. And that includes availability of similar projects from retrofitted buildings. So typically condo and co-op boards, they want to see a project that has had success in a similar building like theirs. And although we have plenty of new construction or gut renovations that have used heat pumps, we haven't really seen that in multifamily buildings retrofitted here in New York City, which is a big factor, because although there are some in other areas, New Yorkers really like to see other New York projects that have been successful. Another one that's not as big of an issue, but has come up during these conversations, is disruption to tenants. So normally when you're replacing a boiler, let's say at the end of useful life, the work is being done primarily downstairs in the boiler room or in the mechanical room. Whereas with the heat pump, you are having to go into every single apartment, and there is some disruption there, similar to window replacements. And that's a huge project for a building. So that has been another factor that's come up. And then the last, again, not as big of an issue, but is still there, is conflicting information in the market. So, and what I mean by that is there may be an engineer that comes in that provides some information and data on the cost and the savings of the project, which at times can conflict with a contractor's information. So that uncertainty makes them feel uncomfortable with moving forward with a project.
Great, thank you, Kelly. I want to move on to a couple questions around policy development, but before I do any of the other panelists want to weigh in on this question of owner perspective and what's holding owners back?
Well, from the feedback I've gotten, no one wants to be the quote unquote guinea pig. So while it's not a brand new technology, it's not widely used, so no one wants to be the first to use it. So I think it's a matter of getting some more demonstration projects out there and getting people more comfortable with the technology. But as you stated before, we have to go electric. So at some point, we're all going there.
We got to get there.
Mm-hmm.
Great. So there's been a ton of policy development on this topic in the recent years, and particularly in recent months. NYSERDA, along with the state's utilities, recently released a statewide heat pump plan and sort of implementation strategy. Donovan, can you walk us through some of the highlights from that plan and how it will help multifamily buildings to go electric?
Sure. So as you're aware, all of the heat pump incentives are now transferred to the utility. So let's say New York City, Con Ed will be handling and managing all of the incentive programs. It really is a robust incentive. I know Chris will talk more about that. As it relates to multifamily, it'll be a custom measure, so it's not on the printed rate card incentive schedule, but you talk to the commercial team at Con Edison, and again, you'll have some really good incentives. What we're doing now, we're transitioning to what we call market development, and we have an investment plan that we're about to file with DPS for about $230 million to focus on supporting the incentives, with marketing, consumer awareness, workforce development. That's going to be a big thing. I know we'll talk about that a little bit later. As far as multifamily buildings, we have several programs now. As you're aware, our Building of Excellence, Retrofitting New York programs. Emily Dean, who leads our multifamily team, amongst other areas in NYSERDA, we brought on someone recently who I think everyone at Urban Green knows and loves, Russell Unger, to help us develop strategy for multifamily buildings. So really looking forward to what comes out of his work. Also, we're launching another program soon called Empire Big Buildings Challenge, led by Michael Reed on our team. We've also brought in someone that I think everybody within Urban Green knows and loves. Jared Rodriguez has recently joined us as a consultant to help us develop strategies for big buildings, including multifamily buildings. The one thing that I do want to talk about, which I have not talked about before, which I will follow up and send a link to it. We're now offering free screenings for large buildings identified as 10,000 square feet or larger, to determine high-level feasibility for heat pumps, air source heat pumps, VRFs, and ground source heat pumps. It really is a very nice tool, and the hope is that once you use this first level, it gives you a nice, whether it's financially feasible or not, you can go to our Flex Tech study that will get you to a much deeper analysis of what's possible within that site.
That's great. Excellent momentum there. Donovan mentioned that the incentive programs are transitioning from NYSERDA to the utilities. And there's, I think Sean mentioned in the presentation that along with that transition, there's a new injection of about $500 million through 2025 to support those incentives. Chris, can you tell us a little bit about Con Edison's incentive programs around heat pumps, their structure, their process? How's that money going to be spent? And how do you see the heat pump incentives evolving over the next few years?
Absolutely. So of the $500 million that Sean mentioned, about $220 million of that money is going to be coming to the Con Edison service territory over that same next year period. And very exciting for us to be taking over those programs from NYSERDA. Also a challenge. And one of the challenges that we're facing right now as we start to implement the program, of course, is the New York pause and the pandemic. So today we're not out there with contractors talking to customers and installers because it's not the right thing to do to be out there in the public spaces. But we hope that soon that will change and we will be able to get out there and be more active. Generally speaking, though, the incentive structure is going to be available to all Con Edison customers as long as they contribute to the funding for the incentive program, which is the overwhelming majority of our customers do that. And we're going to be offering both air source and ground source incentives. I know that the Urban Green focus is on air source heat pumps, but there's also significant interest in our customer base on ground source, so there'll be incentives for both. The incentive levels will be similar or higher than what we've seen in the past, and I would say that one area where it's going to be meaningfully higher is when customers want to use air source heat pumps as their primary heating source. And there we're going to be, roughly speaking, doubling the incentive to about $2,200 per ton of heating, measured at the air source heat pump's capability when it's 5 degrees out. So in other words, whatever its capability is to heat when it's very cold outside, the incentive will be scaled to that level. For ground source heat pumps, it's going to be about $3,000 per ton of heating. And we talked a little bit earlier about heat pump water heaters. And we will have incentives for that technology as well, rather than providing the incentive on a per ton of heating or BTU basis. That's just going to be $1,000 per unit. And then Donovan mentioned custom incentives for many of our larger customers, and that would definitely be true of a large multifamily building. The numbers will be calculated on a more project-specific basis, based on the amount of energy savings that the customer will achieve by switching from their current fuel source to heat pumps. But we think that they'll be competitive, and we hope that they'll encourage many customers to adopt this technology.
Great.
And Chris, this is Donovan again. If I can add, get my video, one other thing here, because I know we talked about incentives for heat pumps. But a lot of the buildings, particularly the existing buildings, are older buildings, and they're going to need energy efficiency work. They're going to need envelope work, and we strongly encourage that you tighten the envelope to reduce the thermal load before you install the heat pump. And I know we talk a lot about the $450 million for heat pump incentives, but the total New York State clean, well, it's not just clean heat, the new efficiency New York was $3 billion. So there's about $2.5 billion for utilities for electric and gas efficiency programs. So I would, I don't know if Chris can expand on that, but I strongly encourage the building owners to take a look at the upcoming efficiency programs that the utilities will be putting forth before they look to install heat pumps.
It's a great point, Donovan. It gives a sense of the scale of support that's coming. Chris, maybe you can respond to that and also just speak to the idea of linking heat pump incentives and other efficiency incentives like envelope work. What kind of linkage do you anticipate there?
Right. So Donovan raises an excellent point that energy efficiency investment is going up overall. Our regulator, the Public Service Commission, really thinks about heat pumps from the perspective of energy efficiency, and they're looking at what's the use at the site of energy for fuel oil. What would it be if a customer converted to heat pumps? And there's an energy savings there, and so they think of heat pumps as an energy efficiency measure. He's absolutely right as well that doing building envelope work, particularly in kind of the older building stock in New York, can be critical to the success of a project, because it allows you to kind of right size the project, and you'll use less electricity. You'll be more comfortable. You'll be able to purchase a somewhat smaller system. There are a whole ton of reasons why doing that first is a good thing to do. I will note two points of caution there. One is that building envelope, particularly kind of deep building envelope retrofits, can be some of the most costly investments to make. And so, a lot of the state's utilities programs really have focused on other measures that reduce energy usage at a lower kind of cost per kWh of energy reduced. And then the other point of caution I would say is that if you go to a customer and say, not only are you going to have to tear up your building to install a heat pump, but we also highly recommend that you make these building envelope upgrades simultaneously, that can be a little bit daunting for customers. And I know some of our installation partners have a preference that we not tie heat pump incentives to building envelope upgrades. So I think there's a there's kind of a balance that we have to strike there between the benefits of doing those building upgrades and the possibility that we inadvertently scare customers away because it increases the complexity of their projects. And I think going back to Sean's original point, we really need some good examples of retrofits having done this so that people are not scared. You know, people who run buildings, co-op boards, and so forth are not discouraged from taking on these types of challenges.
Great, thanks, Chris. So that's some interesting ideas around solving the financial puzzle of heat pumps. Let's talk about workforce and workforce development. So we need a trained and ready workforce to get heat pumps to scale. There's no question about that. Kelly, I want to start with you because I know you deal with training with property managers in the First Service portfolio, but this definitely touches Donovan and Chris as well, so all invited to reply. Do we have enough contractors who have experience in both multifamily retrofits and familiarity with heat pump installation to ramp up these projects? If not, how do we get there?
I think I'd start by saying that there are plenty of contractors out there that are installing heat pumps right now, but not doing the large-scale retrofits for multifamily that we're talking about right now. You know, I was a HVAC contractor. I worked for one 15 years ago, and we were installing heat pumps in commercial spaces, you know, back then. And that's still going on now. What I think we need to see more of moving forward is companies that haven't specialized in heat pumps, that are more familiar with doing boiler work, that they come on this journey with us as well as a technology that, you know, they can be successful with as well. Also, you know, maintaining equipment is an important factor as well. Not as heavy on heat pumps as boiler maintenance is, but still there is work to be done and training that can be done. With that said, when I was working at an HVAC company, I had our staff attend a NYSERDA program back then that was linking energy efficiency with maintenance in apartments and with equipment. And for our guys, our people, our workers, they really started to connect those two concepts. And I think more programs like that are connecting the dots, if you will help us, you know, scale heat pumps moving forward and bring contractors on this journey with us.
Great, thanks, Kelly. Donovan, Chris,
Sure.
do you have anything to add on workforce development?
Sure. This is an extremely high priority area for NYSERDA. We're investing approximately $100 million over the next 5 years for workforce training. 38 million of that is specifically for heat pumps, but the other covers building maintenance, on-the-job training, internships, you know. So, and we really want to see more large HVAC contractors, to Kelly's point, coming into the heat pump space, learning how to install heat pumps. So I will put it out there. So Kelly, and Urban Green, I look forward to having a conversation with you to put a group together to develop some trainings to get some of these large HVAC companies to learn how to install heat pumps on a large scale. So we have this support for that, and we have the will to do that.
Excellent.
That's great, and definitely on that journey with you, Donovan. And one other thought that just came to my head. I don't want to leave out the supers, the resident managers, and the building staff of apartment buildings, condo, co-op, and rental buildings. They are so critical to this puzzle. We need them to understand this technology. We need them to be able to troubleshoot when needed. You know, we do training at First Service, but I'd love to see that expanded for, you know, in unions on heat pumps, or, you know, internally or at other programs. I think they're a key piece of this puzzle.
Yeah. Sure. Well, the training, the funding is all encompassing. So it's not just training installers, sales, the whole ecosystem. So yes, we want to train really want to transition to the clean energy economy and train workers from all, walks of life and demographics and socioeconomic environments into this space. So let's have a follow-up conversation and put something good together.
Great, excellent point. We've seen some early movement on heat pumps in the affordable housing sector. Our report touches on some potential opportunities in that sector. Donovan, I'll start with you on this because I know the state's been very focused on this question, and some of that early movement has been through NYSERDA funding and the state's Retrofit New York program. Is the low and moderate income sector a good initial target here, a good starting point? And if so, what's the plan there? Okay,
well, another extremely important and high priority area, particularly as it relates to the CLCPA, the Climate Leadership and Community Protection Act. It's really about helping the LMI. Just so you're aware, a little over 55% of all New York State residents are classified as categorized as LMI. When you get into New York City, the majority of the buildings, multifamily buildings in New York City, are affordable housing. So yes, it's extremely important. So the team lead here at NYSERDA, Chris Cole, he's working with the utilities now on a joint filing, which is supposed to be filed June 15th on the overall joint utility NYSERDA LMI plan and strategy. So let's hold off for that. But also too, separately, we're also filing a $30 million investment plan specifically to help the LMI sector doing demonstration projects, maybe putting a little adder on some of the incentives, maybe not, because I think the incentives on the utility side will be robust, but also doing feasibility studies, identifying barriers because there are a lot of regulatory barriers in some instances. So I guess we just talked about two big pieces: workforce development and LMI. They sort of go hand in hand, and also training the LMI community to get into the space as well too. That's equally as important. So more to come on that. Look out for the filing on June 15th.
Great, thank you, Donovan. So, Chris, Rob, when an owner replaces a fossil fuel-based system, a boiler, natural gas, oil, with a heat pump system, the customer's electricity usage is going to go up, even if overall energy consumption is reduced. We may also be adding electric cooling to spaces that didn't have it before. What does that mean for a customer's electricity bills? Can you talk about Con Edison's rate offerings for heat pump customers and how they're evolving right now?
Sure. So clearly, no matter how efficient any customer makes their living space, if they're converting their heating fuel effectively from natural gas or fuel oil to electricity, their consumption of electricity will go up. And I just want to point back to the slide that Sean used talking about demand-based rates. We think that those rates with the proper installations can provide customers with meaningful savings and really reduce their effective kilowatt hour rate. So we have, as a result of our recently approved rate filing, we do have a rate for customers. It's not exclusively for heat pump customers. It can be used by any customer to opt in, and it will use the customer's peak demand in order to determine their delivery bill. They'll still get charged for the commodity, the electricity that they consume on a kilowatt hour basis. But by converting to demand-based rates, we think customers can meaningfully reduce their electric bills, and we think that that's a good thing. One caveat to that is because the bill is based on the peak usage and not on the volume of usage, it's really critically important for installers to be aware of that and design systems that do things to minimize peak. And so that may mean, for example, if you're a geothermal system developer, stay away from installing resistance strips in your system as a way to kind of quickly get spaces up to the desired temperature, because those resistance strips can really increase peak and that will be a bad thing for for your bill under this type of rate. So that rate, by the way, is available today. Call in 1-800-75-CON-ED, and it's SC1 rate 4, and make sure to talk to your HVAC installer before you sign up for that rate.
Great, thank you, Chris. So Sean in his presentation touched briefly on the issue of refrigerants. There are uncertainties on the owner side. There are also we hear often concerns voiced about the global warming potential of refrigerants and their leakage. I'm going to throw this to any of you who can respond. What are the refrigerant risks we should be thinking about, and in particular to an owner looking at installing heat pumps today?
I can take a first crack at that one. So absolutely, refrigerants do have a higher global warming potential than things like carbon dioxide or even methane. So it's more critical than ever to make sure that the person who will install the heat pump is well trained, and specifically trained by the manufacturer of the heat pump you're going to install. So definitely don't take any shortcuts there. I've gone through this experience myself. Had to get a different contractor in to fix some of the problems when we had a leak. But the other thing that we found in the research was that while a lot of folks are doing some accounting on how much refrigerant is leaked and what that means, fewer are doing work on looking at natural gas, so fugitive methane leaks in our distribution, in our other oil and gas infrastructure. So one of the things we found is that actually today, methane emissions count for more of global warming than refrigerants do. And that's something that often isn't mentioned in this discussion. So fugitive gas leaks are a huge problem. And by ending our dependence on natural gas, we can get rid of that piece of it.
Yeah. So refrigerants is the big issue going forward. That's the magic sauce within heat pumps, right? It's refrigerants. As you're probably aware, HFCs are going to be banned in New York State starting 2030, and R410A is what's used in the refrigerant used in most heat pumps today. So that's going to need to be addressed. We're actually looking at low global warming potential refrigerants and doing some research on that. We know CO2 is good. There's no perfect refrigerant, so either it's toxic or flammable. So we have to address those, but clearly it needs to be addressed. We are also looking at technologies that are in Europe right now. There's several manufacturers that have what I would call air-to-water systems, VRF systems, and there are also some water-to-water systems. So there's some heat pump technologies that are out there that are commercially viable in Europe and other parts of the world that we're looking to see how we can bring here to the States and commercialize. So if we can get these air-to-water VRF systems in the States where you're circulating water throughout a building rather than refrigerants, it dramatically reduces the global warming potential. And leakage, obviously, it's like a hydronic system. If it leaks, it's water. It's not refrigerants. And those technologies are going to be coming sooner than we think, probably in the next 3 to 5 years.
Great. Thank you, Donovan. So I want to just acknowledge that we're in very unprecedented and challenging times with COVID-19, and ask all of you what this period and the economic impacts to come means for the push to electrify New York City's multifamily buildings in the months and maybe years ahead. I'll invite any general thoughts on sort of how folks should be thinking about this challenge and how it relates to building electrification.
This is Chris at Con Ed. I can take a quick shot at that. So I think nobody at Con Edison has any intention of stopping the push to clean energy during this time. We want to push our programs out there into the public as quickly as we possibly can. And I'll also just note that in a economic downturn like I think we're likely to experience, having some economic demand drivers can be incredibly important to bring the economy back to where it can be, to its full potential. I think in past years that it was popular to focus on, austerity, both at the, governmental level and sometimes, down to the utility level. And I think we all understand the need for the state to balance its budget. But if we can move these clean energy programs forward, I think they can be, the seed from which the kind of regrowth of the economy can start. So we plan to move those forward as expeditiously as possible, and we believe we're going to get just tons of support from the Public Service Commission, NYSERDA, and other policymakers on doing that.
Great.
Yeah, I mean, certainly you're going to get a lot of support. Once we come off pause and get the economy going back again, I guess the silver lining in this terrible cloud is there are a lot of people that are unemployed right now. But as I mentioned, we're going to be investing $100 million in workforce development. So we will have a really good pool of people looking for work that we can try to transition into the space. One of the things that we're doing is really more for residential and small commercial. We're going to be coming out with a zero interest loan for the term of the loans, 5, 10, and 15-year loans, up to $25,000 to help jumpstart and try to get consumers over the hurdle to install heat pumps. And another shift from a marketing and messaging standpoint, we're going to talk more about the health benefits and indoor air quality. I know you mentioned that in the study as well, because we're spending a lot more time indoors and will continue. I think the work remotely is going to be the new norm. So those are some of the things we're doing. But yes, whatever the utilities, contractors, or the public needs and support, we will do what we can to help out.
Great, thank you all. So we're going to transition to some audience Q&A now. And I want to remind the audience again that you can enter questions on Slido on your screen below your video screen. You should see a box to enter, and then you can upvote the questions that are there to make them more likely to show up in the discussion. So let's start with a broad question here. All of you were involved in extensive discussions over the last year with our group of experts and advisors on the challenges of heat pumps, the potential opportunities. And we have an audience question asking what you found most surprising in the Going Electric report or the discussions that led up to it.
So I would say the most surprising thing was that there is this wide spectrum of belief within consultants to building owners of how well a heat pump can perform in a cold climate. And even I was impressed by how far we've come in the last decade in terms of performance. So the manufacturers have made a lot of innovations in the last 10 years that have brought us way beyond packaged terminal heat pumps that turn off at 40 degrees Fahrenheit. So that was very surprising and really heartening to hear how far we've come.
Great, thanks, Sean. Chris, Kelly, Donovan, any of you have particular?
Yeah, well, I like the chart that showed, it wasn't surprising. I live and breathe this for the last 5 years, so I'm very familiar, but looking at that chart, say, here are the best cases, here are the ones that are good, here are the ones that's fair. 480 buildings right now, that's a good starting point. So and that's a good low-hanging fruit. Let's identify those buildings and do all we can to start there. That will keep us busy for a couple of years while we get the other ones ready.
Great.
I have something that was surprising to me a little bit more personally from the Con Edison perspective, which is, I heard the notion expressed that, if a building increases its electric usage, and that requires, additional infrastructure that Con Edison has to build to support that building's higher usage. And I'm talking about up to the meter. After the meter, that's for the customer to address. But up to the meter, if we have to build more infrastructure, that we would somehow charge the customer for that infrastructure. And I heard it from a couple of people, and not true. If a building needs to increase its electric usage, and we need to build out our infrastructure in the street to support that, we do that through the rates that we collect from all customers, and your rate will not change if you need additional Con Edison infrastructure to be built to support your move to electrification. So it's just kind of a good reminder that things that are sometimes obvious within Con Edison and within, big organizations are not always obvious to others outside of that organization.
Thanks, Chris.
For me, there wasn't really, I would say, anything shocking or super surprising that came out of the report from my perspective. Sean and the team did such a great job of being able to incorporate everybody's thoughts and experiences in trying to move projects forward. What I really did like, as Donovan said, as well as those 3 key areas, that we can focus on. That for me, as someone, where I sit, that is going to help me kind of focus moving forward on, which buildings I'm going to want to spend a little bit more time in pushing the technology. But one of the things that I will also add is that more people are asking for the comparison of upgrading to heat pumps now. I'd love to see that with any type of major heating replacement in a building, and hopefully we get to that point where if a company is coming in saying you're at end of useful life for your boiler, that automatically you're also looking at your electric option. But we're not completely there yet. But we're seeing more of it, which is a good sign.
Great. Thanks, Kelly. Chris, you touched briefly on the electrical upgrade question, but from the utility infrastructure perspective, we have an audience question on how hard is it to upgrade the electrical capacity of buildings if necessary to take the additional load of heat pumps. So this is more on the building side. How hard is it to implement electrical upgrades in the building, and what does that entail? And I know we don't have any electricians on the call here. Sean, do you want to take a crack at that?
I will say that in the meetings, it was suggested that could actually double the cost of the heat pump installation. That is probably not the case in all buildings. But the wiring and running new wiring to each apartment and upgrading their circuit breakers could be expensive. And you would have to then visit each apartment, but you're going to have to do that anyway with the heat pump. And there are also a lot of ingenious workarounds to try to get the capacity that you need into your apartment, possibly while switching loads. So making sure that the heat pump is not operating at the same time as other high demand appliances.
Great, thanks, Sean. Any other thoughts on the challenge of electrical upgrades? And if not?
Well, it is a challenge, and it has to be done in some of the larger buildings have to change the vault. So that's something that has to be factored into the CapEx and may be included in incentive considerations.
Okay, great. Donovan, you can leave your video on if you'd like, since we're in the panelist section now. Our next question is on technological gaps. So the question is, what technology would you like to see that isn't currently available in the market? Are there gaps that you've seen in your experience that would help move this forward?
Well, so far we do have an innovations group. We're doing a lot of R&D and have some ponds out looking for new technologies. A lot of manufacturers now are doing M&V to bring new technologies to market, but there are also some existing technologies that I mentioned earlier in Europe that's commercially viable, that are low global warming potential. I mentioned these air-to-water VRF systems, and there's some water-to-water systems. So we really want to take a look at what's out there, what's working, and then long term. I mean, one technology that we really want to see in this market is cold climate package terminal heat pumps. And we are doing a study on that right now to develop that. But whoever can bring that, we're also looking at we call energy pods where everything's in the box, the ventilator, the heat pump, all that stuff. So there are things out there, and hopefully in the coming months we'll be able to talk about some of the projects that we're exploring and doing research on.
I have a thought on that one.
Please.
Two things that I think would be great to see, and I think maybe the core technology is out there already, but somebody just needs to package it up the right way. The first is, one of the issues with heat pumps, particularly in multifamily buildings, is, heat is typically included in the rent, but sometimes, for some configurations of heat pumps, it may make more sense to put the heat pumps usage on the tenant's electric meter. But if heat is included in the rent, you can't include, the cost of the heating onto that tenant. So I think it would be great if there was a real scalable solution for buildings who want to convert to heat pumps, are required to provide heating to their tenants, but are not required to provide cooling, and a kind of a billing and metering system that would handle that, easily and seamlessly for the customer. The other piece thing that I would love to see is, there's this, I know the Urban Green report focused on air source heat pumps, but I think ground source heat pumps have some unique advantages compared to air source. Their efficiency tends not to drop off as the outside air gets cold. But doing geothermal in New York, in kind of dense urban spaces, is super challenging. And I think it would be great to see, a company to start to specialize in doing kind of geothermal, take on a multifamily project in New York City, figure out how to do a geothermal well in the basement, where you only have, 6 feet or 8 feet of headroom to do that drilling. That's super hard to do, but I think it would be great to have more options in New York City for geothermal.
Yeah, and you know what? There is a technology. There is a drilling rig that you can actually take down into the basement and start drilling boreholes. So yes, that'll probably be coming soon. The other area is water. Actually, water is the best heat exchange in Manhattan, certainly surrounded by water. So utilizing the waterways around. Obviously, there's other regulatory issues, but there are companies looking at that as well too, just utilizing bodies of water.
Great. So we have a question about how the experience of heat pumps. And the question is, what will the noise level be with heat pumps? Will it sound like a window AC all year long? Can one or more of you speak to what a tenant or resident's experience is once they have heat pumps installed?
Well, I can.
That's like what it sounds like now. The silence, that's like, it's not completely silent, but it's the quietest HVAC system you will buy.
Yeah, I'm going to agree with Donovan in the sense that we actually, a lot of buildings have PTAC units in their apartments, or a water source heat pump even in their apartments that have a compressor that is running and a fan, and it's pretty loud. You can hear it turn on and off, whenever it starts. So compared to an air source heat pump where you only have the evaporator in your space, it's significantly less noisy.
Yep, I currently live with heat pumps, air source heat pumps, and they're miraculous. Super quiet. I actually sometimes cannot tell if they're actually heating the space unless I walk up to it and take a look at the status light or feel the heat being blown on me. So it's really something you don't notice in terms of noise.
Great. So next question is, where would you put condensing units and refrigerant piping in existing multifamily buildings? This is to the logistics of actually retrofitting a multifamily building with tenants in place or not. Where does that equipment go?
It can go on the side of the buildings, on the roof of the buildings. Some, as you saw one example, put in the PTAC slip. those are really the options.
We've also seen some buildings, again, it would have to be checked by the individual building, but we've seen balconies be used for mini splits, which has been good. We've seen row houses for multifamily buildings utilize the space outside of the individual apartment. But there's a lot of different factors that are going to come into play when you're making that decision. But there's options.
Great. And the more projects we get in, the more those options will become apparent. Next question is, can a heat pump really replace a boiler in a hydronic system in a multifamily building or office?
Well, it can replace the hydronic system. The difference is the hydronic system, the water goes up to 180 degrees, and the heat pump may go up to 120 degrees. It's a different kind of comfort, kind of experience, but heat pumps are replacing boilers and furnaces all day long. That's what they replace.
Yeah, I'll also speak to that. I mean, Donovan mentioned the temperature difference. And if a building wanted to make that hydronic switch to be heat pump ready, they would have to put in more heating area. So you wouldn't want to size your radiators for 180 degree water. You'd want to do something lower than that, like 120 or 140. So you're going to have more convector space for a heat pump ready hydronic system.
Going back to the question of what heat pumps and heat pumps at scale means for electricity usage, we have a question hitting on that idea that electricity usage might go up. What does that mean from the broader grid perspective? What are we looking at in terms of peak and timing for the impact of heat pumps at scale?
I'll take that one. So I think a lot depends on some factors that we don't know how they will turn out yet. Things like will customers make major building retrofits to make their envelope much more airtight, or will they not do that? And the impact of heat pumps on the grid depends fairly strongly on that factor. So I think that's important. I think another issue is, how systems are designed. So as I mentioned before, the peak load is what drives demand-based rates, and one of the reasons that we think using that as a way to calculate a customer's delivery bill, not the energy, but just the delivery portion of their electric bill, is that the factor that really drives Con Edison's costs is the peak. And so it'll be incredibly important, I think, for the industry in general as we move to electric heating to come up with ways to mitigate that impact on peak load. So I mentioned before, resistance strips are, not a great idea. I think most mini splits today, cold climate, do not use resistance strips specifically to provide heating. So that's a good thing. And then the other thing that we should recognize is that buildings are only kind of part of the electrification question. The other thing that's going on simultaneously in order for the state to meet its CLCPA goals is the electrification of transportation. And so we have to think carefully about how those two major shifts in energy usage impact the peak. And you certainly wouldn't want electric vehicle charging peaks to overlap with electric heating peaks if you can avoid that, because that could really drive huge increases of peak. So we have to come up with ways to encourage people to charge their EVs and use electricity in ways that mitigates that increase in peak. The overall answer that we usually give people is that, if the state is successful in moving heating and transportation over to electricity, the peak will go up. And the question is how much. If we do it I think well, you could see, an increase in peak, of 2 times. And if you do it less well, then you could see higher increases like that. And depending on that factor, depending on how much the peak increases, that's really going to impact the costs of electric delivery in the state.
Thank you, Chris. We have a couple questions touching on landmark regulation. And Kelly, I'm wondering if any of the FirstService managed buildings are landmark buildings, and if you could speak at all to the challenges of heat pump retrofits in those buildings. Will it be more costly? Are there particular considerations?
Yes, we do have a lot of landmark buildings actually in our portfolio. I don't think that one of them yet has gone through the process of evaluating heat pump conversion. We've one that's beginning that journey right now, so I should have more information. But just like any other major project that happens in a landmark building, you have to be very aware of rules that you can't change anything about the look of
the question. Okay, so that'll be an evolving challenge, I think. We also have a couple questions touching on NYCHA specifically. Can any of you speak to the efforts to electrify some of NYCHA's buildings and deal with the legacy fossil fuel steam systems in those buildings?
Yeah, from an NYCHA standpoint, the issue with NYCHA, which again, that way they'll do incentives, is that they don't pay into the system benefits charge, so we really can't spend, but my understanding is some do. So we are engaging with them. We talk to them, but there's little we can do from a financial standpoint to support their efforts.
Yeah, I can speak briefly to what NYCHA is working on. They were actually involved on the advisory board, as well as the engineers who are doing the feasibility study and the design for them. So they have some heat pumps that are going into one of their buildings that they explored the entire portfolio to figure out which building would be best in terms of, do they have a heating system that can continue running for the other apartments while they experiment on one floor of the building, as well as what's the electrical capacity. So they're going forward with that pilot program to see how their tenants respond to it and how the construction process goes, as well as the cost.
Thank you, Sean. So we have a question coming back to refrigerants. We touched on this a little bit, but I don't think we hit this specific issue. The question is for a centralized VRF system. What are the drawbacks, if any, to running refrigerant lines in occupied spaces and through common areas? And I think this is getting at some of the health and safety questions that often come up.
Well, you'd have to talk to one of the contractors that they've done. I mean, it's been done. The concern is leakage, but that's why I said we're really looking for some of these newer technologies in Europe, these air-to-water systems. So it's an issue currently that really needs to be addressed. But NYCHA's New York City office has a VRF system in it. We all work in that space. At least we used to work in that space 2 months ago.
Right.
Yeah, it is a concern. There is an ASHRAE standard that actually is meant to take care of those and give designers a specification that they can look to avoid the risks. And the risk is really if you have a central system that had a leak and then it discharged into one small area. That would be a big concern for something like a hotel. But hotels have done these. So the design actually is the thing that will take care of that by making sure that you contain large volumes of refrigerants in separate pieces of the heat pump system, or make sure that a small space is able to be ventilated in case of an emergency like that.
We've gotten a couple questions on the Venn diagram of buildings to target for heat pump retrofits that Sean showed and Kelly alluded to. Sean, we have a question asking if that list of 480 buildings is available to the public. Can you just speak briefly to how the data behind that and where people could access it?
Sure. So the Venn diagram, there's more detail in the report on how many buildings are in each one of those bins. but we cannot make a list of those buildings. There is some private confidential information that we use from the audit data and benchmarking data to get those bins. But making that list, or we have the list, but working with other policymakers on how to most effectively use that list is something that we're thinking about.
Great, thank you. Our next question is focused on steam to hydronic conversions, which came up as kind of a one step at a time strategy for heat pump retrofits. Are there recent case studies of doing that conversion, converting from a 1 or 2 pipe steam building to a hydronic system in New York City? Does anybody know, has anybody seen that in their experience? No, it sounds like not. It doesn't mean it hasn't been done, but it's an expensive and emerging option. Next question is, if deep retrofits are not required, not absolutely necessary to make air source heat pumps work in an efficient manner for a building, what type of minimum envelope or weatherization upgrades are needed? Kelly, is that something you can speak to?
So I think that we definitely would want to make sure the units were sized properly, and that means that we want to take care of kind of like the low-hanging fruit in the apartments. But to Chris's point, sometimes those projects can be very costly. Replacing windows is a very expensive project to take on. The things that come to my mind right away that you'd want to take care of is making sure that at least the windows are sealed and insulated properly. If you have a PTAC, through the wall unit, but you're not going to be utilizing that anymore, to make sure that that's insulated the best that you can if you're not covering up the facade and reducing that hole size. Those are things that are going to be important. Again, it's important to also realize that a lot of our steam systems are oversized as they are now. So resizing and calculating how much heat and cooling is needed in the apartments is going to be something that's very important during this process.
Thank you, Kelly. We have a couple questions about the Con Edison incentive programs that were mentioned, and one specifically, Chris, does Con Edison have incentives for air source heat pumps that are targeting the Con Ed neighborhood program zones, which I believe are areas of particular grid stress that need peak load attention? Do you know whether that's part of the focus?
So yeah, the Con Ed neighborhood program is, basically that's, I believe, the BQDM, what we internally have called the BQDM program, which was one of the first, efforts by a utility to offset the need for electric infrastructure, using kind of demand side reductions. I do not know the answer to the question of whether there's kind of something separate and larger for customers who want to do heat pumps in that particular part of the service territory. I will say generally that, as I mentioned before, the incentives for air source heat pumps that are the primary, going to be the primary heating source for our customers' building are really going up in our new incentive structure. But sorry, don't know the answer to that more detailed question.
Okay. One question here on the weather limitations of air source heat pumps and potential backup capacity that's needed. Sean, you touched briefly on that with the COPs, the efficiency performance ratings for heat pumps. Sean, can you or others speak to potential weather limitations or lack thereof in this context?
One of the requirements, or the main requirements for air source heat pumps in the new New York State Clean Heat Program, you have to be on the NEEP list, and you have to have a COP of 1.75 down to 5 degrees. So we just have to figure how many days do we get 5 degrees in New York City.
Yep, exactly. After that 5-degree point, the capacity does start to fall more quickly. But really, I mean, in New York City, that's going to be a rare occurrence. So we shouldn't be sizing for that event. And that is, I mean, typically design engineers do look for the peak design day, and maybe that's something that we don't do as frequently with air source heat pumps. But the capacities have been really pretty steady. It's not a precipitous fall down to 5 degrees.
So we got just a couple minutes left. I want to conclude with a broader question for each of you about what you think are the most important 1 or 2 policy or utility actions to support this transition, to support getting heat pump retrofits to scale in New York City's multifamily buildings in the kind of near to medium term. So we've talked about a lot of different challenges and some approaches to addressing them. What do you think are sort of the top 1 or 2 priorities there that we should be really focused on?
Some of them I think we're doing already. I think that, the incentive levels, adjusting higher for air source heat pumps, I think is really going to help the market take off. So I think that's critical. And then I think that, we talked about the education, the importance of education and getting out to contractors. I'm on my building co-op board actually, and that co-op board gets advice from our natural gas, the guy who maintains our natural gas furnace, and he's never heard of a heat pump. I think the way you get co-op and condo boards to really move on this heat pump idea is you get to those fuel oil and those natural gas furnace O&M folks, and make them realize that this is an opportunity for them, and to talk to their clients because they are often kind of the trusted energy advisor when it comes to heating a building. So I think that communication and education aspect is critical there. Otherwise, I think the state is doing the right things in terms of incentives.
Great. Donovan, Kelly, did Chris pretty much get it all right, or you got anything to add to that?
Well, I'll add on to that a little bit. I agree with Chris a lot that definitely the boiler furnace companies are part of that. We need to bring them on this journey, as we talked about before. But I really think that we need to make a requirement for any heating replacement that where they have to look at an electrical option to bring it forward to the board, the condo co-op board, or the owner of a rental building. I think that will help decision makers just look at it. If they don't know about it, how are they going to make a decision, to move forward with that? So I think that will help. And then, one thing we didn't completely touch upon, but I do want to take a moment and say that, availability of data for apartment use is something that I think will help us, individuals in apartments, understand their electricity usage. Now, real-time meters are definitely going to do that if people use the Con Edison app and look at their real-time information. But I would love to see more technology in the home, in your apartment, that's showing energy usage by device so that you can make those educated decisions of, okay, I'm going to, as Sean was talking about, not run my hair dryer or my dishwasher at the same time where I'm running my heat pump. I think people just need to get more comfortable with how much energy devices use.
Great, thanks, Kelly. Donovan, we're pretty much at time, but I'm going to give you a chance for 1 or 2 last
thing, I'll put it out there. We want to educate Chris's facilities person, and I'll put one proposal out there. Maybe Urban Green, NYSERDA, Con Ed, and we partnered with a training provider to provide training for these facilities managers in New York City that manage these multifamily buildings. I put that out there, and I'd like to do that.
Fantastic. We'd love to talk about that further. So we're at time. Let's give a virtual round of applause to all of our panelists. I think you can tell from the range and depth of discussion today that we're really at the cutting edge of some serious thinking about research gaps and policy development, building technology, business practices to tackle the long-term carbon challenges for New York City. It's exciting to see some of the pieces coming together, and we expect a lot more in the years ahead